Hello, my name is Mr. Tohak, and today I'll be doing a demonstration on Geometry Sketchpad regarding quadrilaterals. We shall begin by addressing a couple of standards: css.math.content.hsg.co.a.1, which states no precise definitions of angle, circle, perpendicular line, parallel line, and line segment based on the undefined notions of point, line, distance along the line, and distance around a circular arc. Second will be css.math.content.hsg.co.c.11, which says proof theorems about parallelograms. Theorems include opposite sides are congruent, opposite angles are congruent, the diagonals of a parallelogram bisect each other, and conversely, rectangles are parallelograms with congruent diagonals. We'll begin by creating a quadrilateral. This can be done using the segment tool. From this, we'll use line segments to create a quadrilateral. We'll then use the label tool to label each point A, B, C, and D. Then by going back to the pointer tool, clicking on each line segment, and then clicking the construct button and then the midpoint button, we'll create midpoints. We'll repeat this for each side. And then label them. We will then reselect our segment tool and connect each of the midpoints to each other, creating a new quadrilateral. We will call this quadrilateral the midpoint quadrilateral, and from here we can make three conjectures. The first conjecture will be that all sides will always be parallel. From the naked eye, we can see that the quadrilateral has two pairs of parallel line segments. Furthermore, we can drag around the points and see that no matter how they are dragged, they are still parallel. These parallel line segments will be lines HE, GF, and EF, HG. Using the measure tool, we can select points E, H, and G, and then selecting angle to see the measure of the angle EHG. We can repeat this process for each angle of the quadrilateral. When angles EHG and HGF are added together, they amount to 180 degrees. And using laws of parallel lines, we can determine that these two line segments will never intersect, furthermore justifying there exist two pairs of parallel lines. The second conjecture will be that the opposite sides or line segments of the quadrilateral will always be congruent. Again, from the naked eye, we can see that the line segments HE and GF, as well as EF and HG, seem to be congruent. We can furthermore test this by measuring each side length. We'll do this by using the pointer tool to click on the line segment, click the measure button, and then length. We can repeat this for FG and see that HE and FG are congruent in length, and this is consistent no matter how the points are dragged around. We can mark these congruent using the marker tool by clicking on the line once. We will repeat this by measuring the other two sides to see if this holds true. And after using the measurement tool again, we can see that EF and GH are also congruent, no matter how the points are dragged around. And we'll then mark this by clicking on the line twice to say these two lines are congruent. Finally, we can say that the midpoint quadrilateral will always be a parallelogram. This follows the geometric habit of mind of generalizing geometric ideas. As in the beginning of this activity, before all the labels and lines, we could see that no matter how the quadrilateral was moved, the midpoint quadrilateral always seemed to be a parallelogram. A parallelogram is defined as a quadrilateral with opposite sides parallel and equal, and from our previous two conjectures, we can see that this holds true. Therefore, the midpoint quadrilateral is a parallelogram. Thank you, and I hope that this presentation on quadrilaterals and parallelograms helped.